Hello everyone, I'm the Product Application Instructor at SenseFuture. Today, we will use the temperature control of crystal as an example to explain how to use our TEC215 series temperature controllers. Nonlinear optical crystals are widely used in laser and other optical systems. Their conversion efficiency and stability are highly sensitive to temperature changes. In addition to variations in ambient temperature, the crystals can also absorb some of the laser energy, leading to a temperature rise. Therefore, stable temperature control of the crystals is required. Let's take a BBO frequency doubling crystal as an example and use the TEC215 temperature controller to regulate its temperature. The temperature control setup for the BBO crystal requires an NTC temperature sensor and a semiconductor cooler. In this case, we are using a standard NTC temperature sensor and a 12 volts, 3 amp semiconductor cooler. The materials needed include TEC215 temperature controller, USB to TTL communication cable, 12 volts power supply, computer, screwdriver and wires. Step 1. Wiring. First, connect the NTC temperature sensor of the BBO frequency doubling crystal temperature control setup to the NTC and COM pins on the temperature controller, without distinguishing between positive and negative terminals. Next, connect the semiconductor thermoelectric cooler to the channel 1 TEC1 interface on the temperature controller, ensuring that you observe the correct polarity. Connect the live wire, neutral wire, and ground wire of the power line to the corresponding terminals of the 12 volts power supply. Make sure not to plug the power cord into the 220 volts mains power yet. Then, connect the positive and negative terminals of the power supply to the VIN and GND pins on the temperature controller, ensuring that you observe the correct polarity. Connect the temperature controller using the USB to TTL communication cable, but do not connect it to the computer yet. After verifying that the wiring is correct, connect the power to the 220 volts mains. Step 2. Software configuration. First, click on the serial port number list. Record the existing serial port numbers, then connect the communication cable to the computer's USB port. Click Refresh and select the newly added serial port number. Click Connect. If the connection is successful, the current actual temperature will be displayed in the temperature display area. Click Sensor Configuration and enter the NTC temperature sensor values, R0 of 10,000 ohms and B of 3950. In this case, since the maximum voltage for the semiconductor thermoelectric cooler is 12 volts and the supply voltage is also 12 volts, the maximum output voltage duty cycle is 12/12 equals 100%. To allow for some margin and avoid damaging the cooler, set the maximum output voltage percentage to 90%. Enter the target temperature, then click PID Auto Tuning. Wait for the auto tuning to complete, which may take several minutes depending on the size of the heat sink. You can also manually adjust the PID parameters to achieve stable temperature control. Enable the output to start temperature control with the temperature controller. This is the actual temperature control performance of the crystal, with stability maintained at ±0.001 degrees Celsius over the long term. This concludes the usage case explanation for the TEC215 series temperature controller. Thank you for watching. Stay tuned for more from SenseFuture. See you next time.